My name is Kainton the Genius, and today we are going to continue with lesson 5 of our R tutorial for data science and machine learning. So we are going to be taking plotting in R 2D. This plotting in R is 2D. In 2D is necessary before you can move on to 3D, which is actually very interesting. So this is what we are going to cover: creating different types of plots, title and labels, shapes and colors of data points, and using grids. Again, I'd like to remind you to subscribe to my channel if you've not subscribed. So click on the subscribe button so that you don't miss an update. And also, if you subscribe, you kind of motivate me to keep making this lesson. So please just subscribe to my channel. Alright, so basically we are going to be using the iris dataset. To get the iris dataset, just load it into the workspace by saying iris. So at this point, we have iris dataset loaded into the workspace. Iris dataset is made up of 5 columns and about 150 rows. So if we say, I think we can say dimension of the iris dataset. Let me see. So 150 rows and 5 columns. So to view the first 5 records, you can just say head iris. It shows us the first 5 records. Since we are doing a 2D plot, we are going to be plotting 2 columns. Of course, 2D takes only 2 dimensions, x and y. So let's try to plot the sepal length, this sepal length and sepal width, the first 2. This serial number 1, 2, 3, 4, 5, 6 is not part of the data set. It's just a serial number. So to plot, you simply first maybe we can just extract these 2 columns into another data into another variable. So let's call it my data equals. Already you know that you can do something like iris, all the rows, and then columns 1 and column 2. So at this point we have my data. So if I say dimension my data, you can see that it's 150 rows and 5 columns. And if I say head my data, you can see that it only have 2 items, which we can actually use for plotting 2D. So to plot 2D, you can just say plots and you say my data. So it's this easy. We have a 2D plot out there. Anyway, we can just add some things to make it look cool. Let's say we want to make the plot to be solid. So to do that, say PCH equals 16. And now you have, what am I doing here? Sorry, so let's say PCH is equal to 16 and close. So you can see you have a solid plot at this point. Let's say PCH is equal to 15. Now it changes the shape to a square. And the same way if you use 17, so you can play around with PCH to see how it works. Just change the numbers a bit and see what you have. Let's try to change the color by adding a color attribute. So you can say color is equal to red. So have color is equal to red out there. Maybe we can also add some titles. So we can say X label equals sepal. Okay, let's say X values, so that we see how it goes. And let's say Y label is equal to Y values, and you can see that it changes the X and Y values labels at the label points. So let's give a title. To give a title, you use main. You use main attribute. Main is equal to tutorial 5. All right, this is tutorial 5. Tutorial 5. All right. All right. So you can see this is tutorial 5, and I've added it. I'm going to clear my screen by pressing Ctrl L on the keyboard. Ctrl L. Another thing we want to do is, this data set, I'm going to just show it, iris data set. Okay, yeah, iris data set. I actually want to say head iris. It's made up of different species, actually 3 different species. Is it possible that we can color separate the species by either the shape of the data points or the color? Is it possible we do something like that? Yes, it's possible. Let's try to separate the species first by the color of the data point. So for ones that are cytosar, we use a different color, and so on and so forth. So to do that, we first create a color array, colors array. So to hold the three colors we are going to use is equal to, so let's say red, blue, and green. Okay, so we've created an array called colors. Now we want these colors to correspond to the species, right? So what I'm saying is that we want this species to correspond to the color. So to do that, simply say colors. So I actually hate this this symbol here, but let me just use it. Colors. Now I'm going to say as dot numeric. So more like we are converting text to kind of behave like numeric. Iris, and this time we are using the species. Alright, so we have colors now represented as numbers. So let's now plot again. So I'm going to say plot. I'm going to, instead of using my data, I'll still use iris data set. And this time, of course, I'm going to do the same thing, columns 1 and column 2. And then I'm going to say PCH. PCH this time is equal to, of course, you can use anything. PCH is equal to 16. This time I can say color is equal to colors. Okay, color is equal to colors. Let's see. Okay, I think I made a mistake. So it's actually call is equal to, sorry, not this. Okay, yeah, so we have some warnings, but at least I actually will clear the screen so that okay, so call is equal to color. So this is what we showed. So just take out this. Call is equal to color. So this is what it should be. I actually don't know why these warnings are coming, but we can see that it separates different items by colors. Again, you can separate them by the shapes. So in this case, we can create shapes. Shapes array shapes is equal to let's say C is made up of 15, 16, and 17. Let's say 15, 16, and 17. All right. So so we also convert the shapes to correspond to the species of the iris data set. So I'm going to say shapes as dot numeric, and I then specify the shape the species column. So it's going to be species. All right. So at this time, instead of using PCH is equal to 15 or 16 or 17, I can just use PCH is equal to shapes. So before I'll do that, give me a second. Let me just clear the screen. So I can say dev.off. Okay. Dev.off requires the function, so take it this way. So now I'm going to plot, and this time instead of saying PCH is 16, I'm going to just say PCH is equal to shapes. So now you can see PCH is equal to shapes. Okay. So it should have given me, okay, let's see. Let me take out the colors first. Use this PCH is equal to shapes. So now, let's see. Okay, so first I need to, let me clear my screen. So I'm going to say shapes. Let me just start all over again. Shapes is equal to 15, 16, and 17, and I'm going to say shapes is equal to shapes as numeric. So I'm going to assign it to replace the existing one this way. Iris species. Alright, so at this point, if I plot iris, the same data set, but this time we are taking columns 1 and column 2, and we are saying PCH, this time is going to be equals shapes. Okay, so this is what we wanted to achieve. So we want them to separate by shapes, alright? One thing I also want to do is to just say color call equal to blue. Okay, perfectly okay. Let me separate by shape and also by color. So let's just do call is equal to colors. Okay, so it's separated by colors as well as by shapes. You may also be asking, how do we do a line plot? So to do a line plot, you simply use the attribute type is equal to line. So just say type equal to L. So you can see it gives you a line. So to see how other things or other options that is available for you, just say plot, and you can see that it gives different types. We have points, which is what we've been doing. We have lines, we have both. We have overplotted histogram. Maybe we can just try to do a histogram. I don't know if histogram is going to apply to this data type. Okay, so we have histogram there and a few other things. So I'll recommend you try to work on it, try to play around with it, because in the next class we are going to be now talking about 3D plotting. I'm going to stop here. I'm also going to thank you for viewing and try other things. For instance, try to add grid line by saying grid is equal to true and stuff like that. So remember to subscribe to my channel. I'm Untitled Chapter, and we see you in the next lesson.